Welcome back to Module 2, Physics. We now move on to kinetics, starting with linear motion, speed, velocity, acceleration, and the equations that describe how objects move in a straight line. Speed and velocity sound similar but are different. Speed is a scalar. Distance traveled divided by time, with no regard for direction. Velocity is a vector. Displacement divided by time, where displacement is the straight line distance from start to end in a specific direction. If a path winds around, the distance traveled can be much greater than the displacement. Uniform motion means traveling at a constant speed, so distance equals speed multiplied by time. On a distance-time graph, this appears as a perfectly straight line, since equal distances are covered in equal time intervals. For example, a speed of 15 meters per second, sustained for 10 seconds, covers 150 meters. Acceleration is the rate of change of velocity, calculated as final velocity minus initial velocity divided by time. It is measured in meters per second squared. Above, the velocity arrows grow longer at each 1 second interval, showing the object continuously speeding up, which is positive acceleration. These three equations of motion, sometimes called the Suvat equations, connect displacement, initial velocity, final velocity, acceleration, and time. V equals U plus AT finds a final velocity. S equals UT plus 1/2 a t squared finds distance. And V squared equals U squared plus 2. AS is useful when time isn't known. Use whichever equation matches the values you already have. A velocity time graph tells you two things at once. The area under the graph gives the distance traveled. The gradient, or slope, of the graph gives the acceleration. A flat horizontal line means zero acceleration, constant velocity, while a rising line means the object is speeding up. Pause the video and try this problem yourself. Using V equals U plus AT, and starting from rest means U is 0. 0 plus 3 times 5 gives a final velocity of 15 meters per second. Question 1. A car travels 150 meters in 10 seconds at a constant speed. What is its speed? The answer is B, 15 meters per second. Question 2. What is acceleration? The answer is B, final velocity minus initial velocity divided by time. Question 3. On a velocity time graph, the area under the graph represents The answer is B, distance traveled. Here is your quick reference. Speed is distance over time. Acceleration is the change in velocity over time. The three Suvat equations connect displacement, initial and final velocity, acceleration, and time. On a velocity time graph, the area gives distance, and the slope gives acceleration. That covers linear motion, speed, velocity, acceleration, the Suvat equations, and velocity time graphs. In the next video, we look at rotational and periodic motion. See you there.